Hi, Liran. Welcome to this expert session for this month. And hi, everyone. Liran would be talking about Node.js security or how we can secure Node.js. So I would like Liran to introduce himself and talk about the projects that he does and the initiative that he's running. I met him in Tel Aviv first, wherein we were discussing about developer community, the podcast or the webinars the team is doing. So the work that the team or he is doing is really amazing. We wanted to have him on the podcast. So I will just give it over to him so that he can introduce himself about the projects. Over to you, Liran.
Thank you, Vandana. Hi, everyone. Just me and Vader here having fun. So basically, yeah, thank you for the intro, Vandana. I think we're going to see a lot of one of those top 10 OWASP SQL injections, XSS, RDoS attacks stuff happening on Node. And I figured it's a good way to also intro and get people aware of the OWASP Node Goat project for that. So definitely going to go into that. As for myself, I'm a developer advocate at Snyk. Snyk is building a lot of open source security stuff, kind of developer first mentality. So if you have any questions on that, just ping me. Other than that, I'm also participating in a Node.js Security working group. It's a lot of incident response, kind of triaging vulnerabilities on the ecosystem. So if you're doing a lot of work on JavaScript or Node.js and sometimes getting those vulnerabilities with like NPM audit or Snyk or something like that. Some chances are that these are stuff coming up from the working group itself, as we're heavily being involved in that. If you want to join that, want to help with processes, doing a triage, getting into this stuff, please ping me. We're always looking for enthusiastic people to help us, catch up with vulnerabilities. You'd be amazed how many of those we get. I'm also the author of Essential Node.js Security. So let me just ping you on that one on LinkPub if you search for that. Vandana, maybe I'll just shoot out like a coupon link for that you can get that basically for free for anyone on the webinar or something. Mm-hmm. It's a book I wrote a couple of years ago, really covering a lot of. It was basically mostly Express, but it's a very Node.js like generic as well. Mm-hmm. So a lot of vulnerabilities, how to harden stuff, like anything from headers, cookies, many of the topics that we'll talk about today as well. So it's a nice write-up. You can also get that as well. So I don't know, should we get started?
Yeah, please go ahead.
All right, cool. So let's get started. NodeGoat. So NodeGoat is an OWASP project. It's been led by a person called Chetan. Hopefully I remember how to pronounce that well. Let me look that up. For you, there's a couple of links there I've given you, but basically this is the GitHub page for it. It's very Node.js and JavaScript heavy. Very educational in terms of this is what we'll be using today. You can set that up through there's like a Heroku one-click deploy button here. Downloading it via Docker or just a vanilla NPM thing. It's kind of based on a MongoDB, so the whole SQL injections, they take a different form inside it, inside this educational thing. So you're gonna need MongoDB to do that. You can use. I'll show you how to use a simple Docker image to do that as well. It's pretty easy. One thing to say about the NodeGoat project is it's been getting a lot of traction recently in terms of getting it up to speed. So Ulysses has been doing a lot of work in terms of him and his team in Spain to help us. It's called a Hack Madrid or something like that. And there's like other like guilds that they are working with in terms of trying to contribute into the project. So the project uses a lot of all technologies like JS Hint and like var declarations all around and stuff like that. It's not ES6 up to date and stuff like that. So what I'm trying to say is basically it is an ongoing effort. And so if you clone the repo as is right now, some things may be unstable, which is why I want to give you this link. And I'm gonna give you all the links after the talk as well, so you don't need to remember or like screenshot anything unless you really want to. But this version is a bit out of date in terms of it just doesn't have those ES6 updates and stuff like that. It doesn't have the testing that we added with Cypress and stuff like that. So it has everything else in it, but it's just a more stable branch of all of it. Plus it has a few vulnerabilities that I added that exist only on this fork. This probably should try and replicate all the stuff that you want to do with this one. But then any questions so far? I'll take that as a no.
Yeah, no questions right now.
All right, cool. All right, so we're gonna work with this one. I do wanna go back here and like mention that NodeGoat is not the only project that is like a vulnerable thing. So if you're like new to OWASP, there's definitely other things like WebGoat and JuiceShop. WebGoat specifically also trying to show not only a Node backend, but also like a Java backend too. There are like links for them. You can go and check them out, and you're probably aware of JuiceShop because Vandana and Tanya are advocating for that basically every other day. So all of those options for you. All right, I don't know. Let's get started, right? So, all right, so to get started with that, I am right now on a local branch here, a specific log injection branch. Let's move to something else. I will go and take the, which one was it? The NoSQL thing. And I'm gonna start with that. So to fire it up, I'm gonna do a Docker run for Mongo. So I already have the image. It's just gonna run it. I'm gonna need this one to have basically just a Docker database, like a Mongo database based on Docker. Let's open another session. In this one, what I need to do is basically pre-populate. We have a Grunt task. Yes, that's also very, very old. Grunt and Gulp and all of those. And that's part of the ongoing work with updating the NodeGoat project. But for this repo, the fork, I still have Grunt here. So if you just do npm run, you'll see that there's should be a run script for, I'm pretty sure there is, for the db seed. Not here for some reason. I can go back. And I'll see the database here. So db seed. If that works all okay, you can see we have updated the database users collection with several users. So the username, the user password, so you can use that to log in. We have some data pre-filled as well. I'll switch branch now again. And let's open a code editor. Or do I have one already? Yeah, I have one, okay. All right, so one of the things that you'll need to get that started with is updating the environment. Right now, I'm using a local MongoDB instance, but the README has some explanations of how to start that up with an mlab thing. So it's like a MongoDB in the cloud. So that's also pretty easy to just sign up to there. And if you don't have Docker locally, or having a problem running MongoDB locally, you can just fire this up as well to a cloud-based MongoDB instance with mlab. But that's what we have so far. So this is okay. And great. And starting this up, we have this Express application server listening up. So we can go ahead and fire this on port 4000. We have the app. So far, all is good. Remembers my password from previous logins as well. The app is very simple. Don't really care about the app itself. Just the vulnerabilities inside it. It's just a simple app anyway. It has a few things like benefits, a logout button. There's a user thing happening here. If you click the header, you actually get into a more let's say expanded view of the retirement savings platform here that we created. It has this dashboard thing. It has some contributions of how you want to split like money across specific contribution types, allocations, memos, update your profile. So all the the simple stuff, giving you a lot of attack vectors, and places to put vulnerabilities in that we can learn from. One thing to say, before we even get started is the NodeGood project has done like an amazing job in terms of documenting all of this. So if you go to, you can go to my fork, but if you go to the main one, doesn't really matter. There's this tutorial guide, which is, it's actually bundled also within, what do we see that? It's actually bundled within the actual, is it an artifact? Oh, I forgot. But it is somewhere here. I don't remember that. Maybe a different branch. But we have the whole tutorial thing actually available for you. So we have the whole OWASP top 10, some other vulnerabilities as well that are not, part of OWASP specifically. But an injection attack, what exactly is, examples of things that are, susceptible functions you do not want to use in secure things. There's a whole video thing showing you how this gets done, walking you through the whole thing. The code itself has comments of what is insecure, what is not, and links to the actual code, and showing you examples in code for that. So you will have all of that. That's all ready for you to just jump up afterwards and and figure it out yourself, or just have a local CDF if you're interested in that. So going back to the app, I'm going to close this. It's a bit it's confusing. So going back into the app, it has this this thing, and one thing that we can go ahead and figure out is let's talk about injection attacks. Now I'm going to go and log out, and this thing behind the scene uses MongoDB, so a NoSQL database, and unlike SQL injections in normal databases, you do not specifically concatenate one string to the other, because it's not a string-based core language. It's more like an object, like a document-based core language. So you would go and do things like where username, and then maybe that is a string, but that may be also be an object, or something else. So through those kind of things, using database, NoSQL databases operators, we can try and run some kind of SQL injection attack. So for example, if you wanted to to see, for example, like an NoSQL injection attack that bypasses login authentication methods, I have this saved on Postman, so you can just use that. Several examples here. We can start off with this NoSQL injection attack. I'll walk you through the whole thing. So basically what we're seeing here is running an API request to localhost 4000, API/login. This is like a specific API login request. Headers don't really matter, except it's like a JSON payload. And as you would expect from a post request to an API login endpoint, you would get, username is admin, password admin. Maybe that works, maybe it doesn't. I'll send it, and we will see. So this doesn't work. You see there's like an invalid username, then the username field, the password field. If I click the preview, you can see this as well. One interesting thing that you can already see here from like an educational platform is it tells you that the username is invalid, which is, not a very good practice. So maybe you just want to say, something very generic like username or password, and not reveal the fact that maybe this username does not exist, or maybe it does, but the password is incorrect. So already it has some interesting, good of those little things that, security considerations that you want to figure out how to do better. If we go to the code for that, let me load that up. So everything is, so there's a server.js thing, which has the entire server configuration. And we do have an index.js one, which is just exposing the Express app. So we can see all the routes here. So there's like app, post, API login. This is uses session handler. I'll open this one up on the file browser, and you can see that there's the structure of server.js and an index.js inside it. And I have views for, so yeah, this is where the tutorial is. Inside the views, but I also have the views for, so this is like a server side. This is not a single page application like built with React or Angular or something like that. It actually uses server-side templating engines, so things like Pug, like EJS, like Dust.js, etc. So all the layout, all the login, everything is concatenated within these files. It has routes for all of the routes that we need. Data is our, the DAOs, basically the models that we need for like collections of users and stuff like that. And assets aren't that interesting. It's for the views. So if we go from here to, we don't care about this view, but if we go to, was that a session one, right? So API login, there we go. So if we go to handle API login request and check what's going on there, we can see this code here. So already here, we see this getting, the request response object, the next middleware by Express. So very common function signature for Express web applications. It is getting the username and password straight from the request body and passing that off to this DAO model for validating API login itself. So it's passing the username, the passwords. It's setting up maybe some kind of error messages. So it will give you off if the login is incorrect, give you a username invalid, password invalid, and we have these to-do notes in terms of what you probably want to fix. So this whole thing, why I mentioned of this being like a really good workshop exercise thing. So this seems pretty I will say straightforward, except if we go to validate API login on the model itself, it's a very simple one. It's a very simple MongoDB call that's going to go into the user's collection, going to find just first one entry that has the same username and password that we will pass it, and we'll fire off the callback, which is the function that we saw before. Now the thing is, like with the result set. Now the thing is, if I'm giving it the username admin and password admin, it is, as we said before, it is incorrect. That's not, we know that this is not the right one. I have another saved query that will save us some time. So as you saw before, when I was seeding the database, the actual password is admin123, like that. If I'll be sending that off, you can see that I'm already logged in. So you see like benefits, from the response, logout. So all the things that I actually need to do, Jendo, all the other things that I actually have in my app. So this actually worked. I am actually logged in. Again, firing this off, logged out. So at this point is, how do we get to the NoSQL injections that would allow us to bypass? Now, for that, we need to figure out a couple of things. So first of all, we're taking the request as is from the body itself, right? So if we go back to the session, we see that we're passing username and password from the body itself. Now, one thing that is really important to understand with Express web applications and basically a lot of other web applications frameworks in Node, but Express is the dominant one, is this one. I'm looking for the setup of it is in Node.js. It is so some big common middlewares. It's like 99% of all like Node.js Express web applications will have this body parser middleware, which is passed to Express. And what this does is it allows the Express app, as it is getting requests, to see if they have like a content type is application JSON. Then it will go ahead and JSON parse the actual payload that is received in the body. And this is what this middleware is doing. This is doing something similar, but for URL encoding. So whatever is happening in the URL like query params and stuff like that will also get encoded properly, or like decoded, right, properly for the apps that we use. So what this actually does is, if we consider this is coming, username and password coming from the request itself, the request body. So at that point, request body is not a string anymore. It can be anything else. So if we have if username is a string, like it is over here, that's nice. But if it's an object, because this is JSON, so if this is whatever other object like that, then our username is going to be an object as well. And when we query, define one column, that's going to be an object as well. And that has some serious side effects with MongoDB, because MongoDB has this architecture that is kind of notoriously famous for, in terms of not doing that perhaps in a very secure manner, is that it allows you to actually apply modifiers like like a regex expressions, like a greater than or less than expressions, to like filter and match this key in the document. But it allows you to do that not via a language construct, so it will not allow you to like things like that, but rather from like input that you just pass to the document itself, which usually tends to be user supplied input, right? Because that's how we like query data. So here, if we just pass something like this, so username is now using a special MongoDB operator called greater than. And the same for password. That's going to be basically anything, because anything is greater than an empty string, whatever text it has. That's going to evaluate to true. But more interestingly is the fact that this is an injection attack that allows us to pass the exact same string like that to the username field here. So this is the whole body parser behind the scenes causing this to happen, because actually parsing it out as a valid object, like a valid JavaScript object that will be passing out as a value to username. So if I run this code, you can see, or you should see, that I'm already, so just by that, I'm already logged in, right? Benefit, log out, I'm already there as a user, just like I was before, just by passing username and password. So there we go. This is like a NoSQL injection, a very, very classic one, a very old one as well. It's not something you should be aware of that. But I would say that out of if you go and just search GitHub for things like people doing a find one on some columns to like do authentication, or like basically for anything else as well, you can just hijack the database for whatever you need. If something allows requests to pass in unsanitized like that, that's already a problem. Mitigating it is you could do something as simple as trying to coerce it to like be a string. So whatever you get, there will be a string and not an object. We can see if that works, for example. Let me restart it, as we don't have anything that like NodeMon that restarts it yet. So you can see already it tells me like invalid username, username, password, etc. for the same request that I sent it now with this NoSQL injection, because it is trying to, we don't have that console log, but it is basically trying to stringify this object, which matches something, like object, something like that. Yeah, so let us go back to the state. There you go. So it's one way to mitigate it. Of course, there are other controls that you should add in order to make this, be properly coded in a secure manner. But that's just one SQL and NoSQL injection happening. Other things that are interesting are how about log injections? So log injections are interesting in terms of, it is something that comes out as I think very very unknown in terms of what is the extent of a log injection, what is it used for, and let's figure this out. So I think I have a branch for that as well. That's where we were before, right? It's the previous branch for log injections. There we go. Okay, make some changes there. What is it? There we go. All right, so we're at the log injection, and let's see if everything works as expected. Great. So I'm logged in. Let's see the code for that. So let's say that I have this login request. just like before, this one is not the API login request. So this is the login request for the app itself. So this is this one basically. And every time someone logs in, if they make a mistake, maybe. So let's go log out again. With an invalid password, I will go ahead, or I think it should have gone and logged it. Let's log in, oh no, set user. Let's see if it's giving it a different username. All right, so when there's no such user, it's gonna go and log this error right to the console, which is attempt to log in with invalid request, invalid user, being whatever. Which is something, generally you would want to have secure logging. This is one of the proactive controls that you want to have in your software app. So this is all, fine and well, except if you think about it, those logs are usually, handled in a way that people might parse them, might render them to an app that actually like view logs. So you can imagine, log services that allows you to distribute logs from different, Node application servers or whatever other application servers. Just view them in a unified view. You can parse, you can query them, etc. But one method of attack here is this vector is where you log something. If I would log username being script whatever, would be interesting if this whole thing gets logged, right? And then this gets somehow parsed in some other view system in HTML that doesn't take care of maybe escaping this username as something that is malicious. But always like an interesting thing. Another thing that is happening with log files usually is people would have monitoring into them and will try to create kind of like alerts to figure out if there's bad things happening in the systems. So another interesting way of log injection is not about trying to access some third-party app that you would use to view the logs or something like that, but maybe kind of do some social engineering / fire off some interesting alerts in an app. So maybe I would go off and do a bad login one. So I don't have this username called Liran Tal. So it's showing me that this doesn't exist. That's great. But I can go now and can add a new line. I could say error invalid transaction attempt by Vandana of. I'm gonna go with that one. How much money do you want, Vandana? Is this okay? $100 million. Right. Let's send that, and that's gonna be invalid, right? That's not gonna. We're not trying to do a NoSQL injection or something like that. But since we have sent out a new line, so a CRLF, a carriage return and a line fade, gonna get into someone was unable to authenticate, fine, whatever. But also at that point we actually injected another line of logs into maybe we're trying to scam someone into looking Vandana as a person that might be not so innocent in doing something harmful in the system, trying to move the fire towards them or whatever. So again, this is like a very simple example, but you would be amazed how many times this will not get properly sanitized, and not just for like SQL inject for like XSS attacks or other examples that you would want, like context that you would want to filter this for with just like a simple just serial level vulnerability that would have there. So here's like the actual proper example of SQL injections is this one. How are we doing with Town Vandana? Do we have, we'll do another one, another demo. So plugging into the app. I don't remember that. Okay. All right, so some other things is, other vulnerabilities we can take a look at are insecure direct object references. So probably like the simplest thing that you can think of This demo uses allocations, so something like going into allocations, and you can see that these allocations of like my stock performance can filter them, based on if I have something bigger, gonna show me an error because that's bigger than those two. But basically, what I would want to do maybe is, this is like viewing just my own stock allocations. Maybe I want to view someone else's. Now the thing is, just cleaning up the URL here. Apparently, this is my user ID. So it's getting the user ID from the query param, and it's using that to actually like filter or like give you the results for that specific user. So what if we were able to give, a different user? Like I know we created two of them. What happens if we do allocations for user two? So it's already giving me, these allocations for user John Doe. Maybe we have user three, we do Will Smith. We're giving the allocations of stocks for Will Smith. So already we have this problem of insecure direct object references because we are using that without actual proper authentication. We do not validate the user. So if you go to something like my route for these allocations, I see that I'm getting the username, which I'm trying to get from the database, from the model, from everything else I needed, but I'm getting that based on my user ID, not the actual authenticated user ID, or different way of maybe trying to validate, authenticate that this is the actual user. So I'm doing this really bad thing. I'm susceptible to this thing. Which is actually quite interesting because insecure direct object references is one of those things that is so simple. Most times you just get it right because it's very logical as well. Like thinking about it. It's not as hard as understanding specific like log injection. Zero left, having to think of different systems that are impacted from what you would do. Or like XSS in different contexts, or like an href or like a CSS or problem like that. But they're like simple stuff. Interestingly enough, I do remember tweeting about that actually just recently. So let me find that one. So interestingly enough, so there is someone running this security newsletter. Actually, just took a break from that. He's been doing an amazing job of doing that. And one of his breaches he was talking about is this, Telefonica was just like exposing millions of records, by something as simple as changing a number in the URL, right? So like the classic example of this insecure direct object references that just happened, for like Telefonica. You can search it up. Telefonica is basically a very big telecom provider, traded in the stock exchanges, and everyone makes those mistakes, even those simple ones that just happens. When did I tweet that? I remember that was like pretty recently. So just a couple of months ago, right? So all of those breaches happening through very simple things like that, not even anything sophisticated as like wearing that hoodie and running some 0 days to do that. So we have that. Some other things that are happening is if you go inside this, we have some stuff here, right? So remember we talked about NoSQL injections and MongoDB. So it has this operator called $var, where it allows you to pass some evaluation into it to do stuff. The thing is, $var also accepts there we go. Also accepts JavaScript as well. So these are the available functions that you can do some JavaScript with. Considers like a slip thing, some other really nasty stuff that you can do, but it can actually just run some JavaScript code as well. Like if you need something custom to do that. So doing something as simple as we need to escape this whole thing for the threshold. So just need to escape this single quote and something like that, and running some JavaScript and closing this again. I can do something like sleep, 5,000 or a little bit one time maybe just to make sure that it runs. Yep, that work. Or it's we need to add it to the allocation and the threshold. So getting user input and there we go. So now threshold is actually going to be sleep 10,000, 10,000, and like that. You can see that the app itself is just waiting for the response to come back. It's still loading. It's not as fast as before. But at that point, we did not like block the node event or something like that. We kind of did like a busy loop thing on the like a blocking IO, non-blocking IO thing on the MongoDB app. So the MongoDB is actually maybe running one connection here. Sorry, one connection here is probably just going to be taken out for this amount of time until something goes back. Didn't find anything, so like we don't even care about that. So this is nice, but you can do something that's far more troublesome, which is if we know that we can run any other JavaScript, we can go and do like an actual busy loop, something like that. That would get the MongoDB to just run this, and like completely lock up in terms of CPU, right? So now it's not just one connection running some sleep, it's actually a busy loop. So if I go off and show you the process CPU consumption, that's already pretty slow. You can already see 100% CPU running by the Docker container thing, which is what we're using to run MongoDB here. So consuming as much as possible. I'm gonna go ahead and stop that. So I already hear my fans starting up. Right, so already like again, like an injection. We also should have see the database again. Right, so CPU is gonna calm down in a few minutes, I hope. But already showing you how we can have this, and why do we need to do that? So maybe thresholds needs to be parsed into its own specific type, not just passed in as just concatenating it. So it's like the classic examples of SQL injections happening in NoSQL databases like MongoDB. If you're not careful about these things being possible, sometimes it's just you would not even think about anyone passing something in. It's like maybe not aware of the word being allowing you to execute any other valid JavaScript expression or something like that. So let's go back to some other things. Maybe one final thing to show you would be again. Talk about regular expressions. I always like this topic because it is somewhat unknown. I think now already pretty known, but have gone pretty much unknown, I think, in the community in terms of its impact. And especially in Node.js-based applications where Node.js is multi-threaded, powering by like several threads behind the scenes to do all of this IO work that you need to do. But the JavaScript that you run is basically run in this event loop because of this event-driven architecture to run applications. So I have this profile thing which requires me to add a bank number, for a bank routing one. To save it. So I'm gonna be a bit lazy and just do that. There we go. Where did username? Yeah, so first name, last name, everything is up to date. So in this example, I have this bank routing thing. Now, if I go to bank routing and trying to figure out what's going on there is profile. So my profile update function uses this regular expression to figure out that I'm giving it no valid numbers kind of prefix and a suffix with a pound or whatever hashtag, whatever you call that, and it's trying to like see that this is valid. So if I try to do anything else, like whatever, nothing, just tells me that this is incorrect. And the thing is, with regular expressions, is they are susceptible to something called denial of service, which is, I think, is pretty surprising if you look at the last 2-3 years of as I was talking to developers, they would not even sometimes recognize this as an attack vector. But regular expressions have these problems of, their state machines are trying to get to like an end state of, going through the whole matching token and then trying to evaluate it to like an end state. So they will go through this state machine trying to back and forth to figure out if this string matches the regex example that we have here. If that's true, that's great. If not, it fails. The thing is, they are susceptible to denial of service because you could provide, if a regex pattern is written incorrectly, not in an optimized way, it is actually possible to get the regex engine into a state where it will try and evaluate every possible step, but for every input given, the actual steps required to evaluate that expression would be a superlinear time. Take a superlinear time in terms of the amount of steps needed to take. So you would need like an exponential amount of time to do that. So one example is, I can go ahead and give it a different one. So I can see here that it's looking for a number. It's trying to match, any given number, and then it repeats that and tries to end it with this bound. So if I would go ahead and try to give it, some number like that, make maybe a bit longer, but I'll try to end it with an exclamation mark, right? Not a bound. It's not working. Is that starting with no? And then more of it. So why is this one? Do you remember trying that out and working as an example? Let's see if we get. Should I try something else? Bank routing number is okay. Okay, this is working as expected. So allow only numbers on a suffix. To do that, anything as simple as ending it with something else should work. Wonder if I need to restart it. Let's see now. And this is okay, that's great. Right, let's go back to tutorial and see how we do regex attacks. So if we give long enough input, it would stall it. Oh, but do I not need to end it with something else? That's interesting. I'm pretty sure that they do. Oh, I do not. So in this example of the regex, I actually do not even need to end it with anything else. And you can see that so now my Node app is trying to run this regex and match it. So this is a pretty long one, so it's going to take a long time to do it. If I run htop again, you can see that my CPU is 100%. So now my Node app is consuming as much CPU as it can to go ahead and validate that regular expressions. At this point, it means that I should not be getting anything from the web app itself, from the Node app unlike the MongoDB before, because that was a MongoDB server-side thing, and now this is a Node app regular expressions denial of attack, so nothing gets served. The event loop is basically blocked until I will go ahead and stop it. You can hear my fans coming up again. And the thing is, you'd be surprised how often this thing happens. So if you know MS, that's coming from like the JavaScript world, that's a very popular package. 35 million downloads a week. So that's pretty popular. And behind the scenes, MS uses regular expressions to go ahead and and see if something is like a number, if it matches 5 days or something like that, and manipulate it. But MS was actually found, several issues with that. Certainly, some regular expression denial of service attacks was found vulnerable to this thing, a couple of times already. And it's not the only one. It's pretty common to, for something like that to happen. There's a whole explanation of, why and how this happens. Um, Going into, I think we do have some kind of a blog thing that explains that somewhere. 2, 3, 5, regular expression. Yep. So this whole thing that is happening with the readers is called the catastrophic backtracking. Basically, to like walk you through the whole thing, there's an example here with a different kind of string, like A, opening brackets, B or C, any amount of C, and repeating pattern on B and C. So anything like that matches because that matches, A, B, or C, and then D. So this is A, only C's, but how often of them that you want, and then matches that again. So you can see that things, as simple as that work just fine. So it is expecting, reminding you that it is expecting to end with a D. And if I will go ahead and try to end it with something else, like an X, so a different thing, character than a D that it expects the string to end with, it's taking a significant amount of time. So from 0.04 seconds to almost 2 seconds, consuming as much CPU as it can, because doing regex as Node is just as CPU bounded task as looping over whatever million or billion elements that you have in an array. So it's going to get CPU time. And this example shows like what's going on, right? Like if you do provide it with 4 or 5 characters of C and then an X, it's going to go through 136 steps to go ahead and try and evaluate that. But as soon as you go ahead and double that or a bit more, it's going to go and exponentially take more time and more steps to do that 65 cases then. And if you go to that regex 101 debugger thing, you can see exactly how this thing works. So it starts off, evaluating A with the pattern, then it needs to go into B or C as capturing group. Starting with B, doesn't find anything, goes to C, finds everything. Plus, it's kind of a greedy matcher thing, so it's gonna take up all of them. Gonna end up the whole capturing group. Does not find anything else in terms of B and C because of the outside plus. It's gonna go and try matching X, but it's not gonna find it. So not gonna find it. So it's backtracking. This is the whole catastrophic backtracking thing algorithm kicking in onto the regex. And this is how regular expressions work. So like backtracking is the way that the regex works. It's not the vulnerability itself. So we would go, and backtrack one. What happens now is like maybe we will try and capture all elements of C, but only with so all of them except one with C plus, and then use the outside plus to capture this extra one. And that matches. That's fine. That works. But then it goes on and try to capture D, and then it doesn't. It isn't able to find it because we have an X. Then it will backtrack. So this is like a short description, but then you will see that it backtracks two characters of C. So doing that takes this whole amount of steps for this kind of character. So you don't even need to provide it with a long like a long string to make that happen. There's this whole blog post here about like why I'm saying it's so very it's a very critical issue, because I do remember we had this with us on Pat. We had this vulnerability in Node.js itself. So one of the core modules called Pat was also susceptible to one of those kind of regular expression denial of service attacks. It was discovered by Jamie, who's doing an amazing job in terms of he has really interesting papers for VDOS study that he and a couple of other people from academia had done as well. I really recommend reading into that. If you go and check the state of open source security, we have studied some of those. So like we looked at vulnerabilities in Node, and VDOS is one of those things that just happen to be found so often in the ecosystem. So if you're using npm modules, things like Validator, which is very popular validating JavaScript, will be both again front end and back end like MS. it uses, regexes to validate some stuff, like, it's something a basic to for, it's something a telephone number. So I would say, as with regular expressions, you probably are not having fun writing them, certainly not reading them. You would probably like push that off to something else, like a library to do that for you, like validator, which is, it's great because we're using open source and it has more scrutiny in terms of more people are looking at it. So if it has a vulnerability, someone will probably find it in due time, which is not the same that can be said on you writing your own regular expressions, unless you really have some kind of like a security code review thing in your teams, and that's something that really works out. They are able to flush these things out. Jamie actually wrote this tool called Fallen Regex Detectors. I have that. There we go. So this is actually a pretty cool project that they came up with throughout all the academic study that you can use. It does provide this as kind of a service thing, but since that's not like really commercial, it may not always work. But you can take this whole thing and run it locally. And what this thing does is it has a couple of ways of working with regexes. One way is you can give it like a source code, and it will go through like grep all the regexes that it can, and try to like exploit them and figure out, like have a watchdog there, figure out if it takes more time than it needed, and then tell you that something is vulnerable to DDoS attacks. Or you can just feed it with like one specific regex pattern, and it will take just one specific one and tell you if that's vulnerable or not as well. So it's like a very interesting project. It is one of those things that you can just tie into your CI. If you're using a lot of regexes, or unsure if you're using them or not, you can push that into a CI thing. And as we're talking about like DevSecOps thing, you can just push that in. Make sure that you're always validating, and all the regexes used in your code does not have vulnerabilities to DDoS attacks. So it's a really really cool project if you want to try that out. I think we went through quite a lot of node codes just to show. Yeah, did I close that? Okay. So if you want to go through some more of that, just a tutorial guide to show you through all of it. There's a DDoS attack here, SSRF as well, in different ways. Some things only exist in my branch. Some of the vulnerabilities that I contributed to the project, I think it is the NoSQL injections one with the login. I do think log injection and DDoS is already in the that's already in the master branch of like the original repo of node codes. So if you go there, that should work for you as well. But again, if you can start cloning this up, and if something doesn't like work as expected, we'd be happy if you just open an issue, tell us about it. But if you just want to get started like really straight away, you can just go ahead and clone my fork for it. That should be a good stable point of time to do that. I think that's about it. So, Vandana, any questions on your side? Are you capturing some questions from people?
Yes. So actually, I don't have questions because the information that you shared was very helpful, because you told everything step by step. And I think if I go back to the repo and I start replicating it, it'll be really easy for me to do it. Or even whosoever is starting on Node.js, it'll be really helpful.
Yep.
I would just say that we want to see you. And apart from that, if you have to summarize, let's say in 5 minutes, or it's just in a couple of lines, how would you talk about, or what would you say about the project?
About node codes.
Right. Node good project.
Yeah. So it's an amazing, I think it's an amazing asset for OWASP, and anyone who wants to practice and learn JavaScript security and Node security as well. As I showed you with the tutorials, so many examples. There's like, it is vulnerable by default, but then you have the comments in the code and the tutorial thing to also like figure out how to do it if you need it. So it has been helpful for me to like run some security workshops based on it, and to get people to like hands-on try exploiting stuff. It has anything from basic like XSS with script alerts to things that are more advanced, like log injections, topics, or like redos attacks and stuff like that. So it is very. I think it is the state which is easily encompassing a really good amount of vulnerabilities that we have in Node. That's like very common to other languages as well. Chetan has done a great work in bringing all of this up. So I would say I think we need a bit more time in terms of just bringing the code base up to date. There's like a lot of end-to-end tests that we're adding as well to ensure that every pull request gets tested as well. But the project has been there for like, for years. I've been using it a couple of years ago already with some successful workshops, people having hands-on experience. Can be used for CTFs as well. I haven't done that before with the project, but I know some other people has. Yeah, I would totally recommend going into the repo and trying Node code out. And you can also help with getting involved and adding more vulnerabilities if you seek for that. I know I've added that before, so that's pretty easy process. Update documentation, update the code, update the examples. That's really great. Yeah, that's kind of about it. I think Node code is a good project.
Great. Thank you so much. If they have to reach out to you, where can they reach you?
So I'm on Twitter on Liran_Tal. You can just ping me. My DMs are open. I'm happy to help with getting involved in Node Goat, in the Node security working group, open source security, whatever I can. So just reach out.
Sure. Any parting words that you want to say?
Stay secure.
Yeah, thank you so much. That was a wonderful session. We will be publishing this session shortly in a day or two. Probably then everyone can take a look at it, whosoever has joined late. Thank you so much, everyone, for joining. And thank you so much, Liran, for the wonderful session. Looking forward to many more collaborations with you.
Had fun. Thank you so much, Vandana, for having me and everyone else watching. I guess I'll see you.
Yeah, thank you so much.